Alright, welcome to Chapter 12 video. This is going to be for Algebra 1 at the Gower School, and we're continuing on with Statistics and Probability, which is our last unit of the year. So this section, 12.1, is going to be all about samples and studies. So it's going to be a lot of vocabulary words, and just identifying that when we're doing statistics on stuff, what kind of words can we use to describe them, and what do those words mean. So first we want to differentiate between a population and a sample. So your population is the group of all the individuals that you're looking at trying to find information about. And then the sample is just the smaller subset that you're actually doing an experiment on or collecting data about or measuring things about. So your sample is a small subset using part of the members of your overall population. And then a common word that comes up over and over when you're doing statistics and surveying or sampling is bias. So bias is an error that results in a misrepresentation of the population. So what this means is your results of your experiment lead you to believe some certain conclusion, but it's not actually true of the greater population, even though it may have been true of your smaller subset. So there's a lot of different ways that this can happen, but anytime your subset is not accurately portraying the overall group, then you're going to get bias. So for example, if you have 100 kids in a school and you only ask one of them what their favorite color is, and then you say, okay, kids at this school think this is the favorite color, it's obviously biased because it's based only on the opinion of one person. So there's a lot of thought process that has to go into picking your sample, the subset that you're going to use, in order to make sure that the answers that your sample gives you are representative of the entire population. Okay, so there's five different ways that you can pick a sample, and each of them has different strengths in depending what you're trying to find. So here they are. Simple random sample. So everybody in your population has an equal random chance to be selected into the sample. Second one, systematic sample. Here's where you have a random starting point, but then you follow a pattern. So for example, if I had everyone line up and I picked every third person, that would be a systematic sample. So like, I'll write it down. Sorry, let's keep it the same. So every third person. So it's not really random in the sense that once I choose the first person, everyone else is determined based on that, but it is still overall not like I'm picking out a certain characteristic, so hopefully then you get a random sample. The next one is a self-selected sample. So here's where you ask for volunteers. Now a self-selected sample usually will have some kind of bias because you have to ask yourself, who is it that's volunteering to be in this group, and are the reason they're volunteering making them have some certain trait that not everyone in the group is going to have. Okay, next one is a convenience sample. So here you're selecting people based on where they are. So this could be maybe you want to go out and ask people something, but if you go out on the street and start asking people who passed you by, then you're only actually talking to people who are out on the street. That may not be representative because there's a lot of other people that stayed home and they're not going to be included in your experiment. And the last one is called a stratified sample. So here's where you separate the population into groups, and then within each group you select some members. So for example, say we're interviewing something at school, instead of just choosing everyone at randomly, we might pick 5 7th graders, 5 8th graders, 5 9th graders, etc. So those 5 will be random, but we make sure we get some from every group. Then that's called a stratified sample. So 5 different ways that you can select members for your groups, and which one is best depends on what you're trying to do. So we'll look at some examples soon that will hopefully make it more clear. And then once you've selected your group that you're going to get information about, there's 3 different ways that you can collect data from them that we'll be looking at. So the first is giving them a survey. So this is a simple list of questions that everybody in the sample group will answer. The second method is called observational study. So this is where you measure or watch the sample group without them being affected. So you're not interfering with anything that they're doing, you're just looking and observing kind of from a distance to see what they do or what they say or how they act. And then the third one is the most intrusive or most hands-on. That's an experiment. So here's where you divide the sample group into two separate sides. One is called an experimental group, and they undergo some kind of change in their environment. So the experimental group, this is very important, this experimental group has a change in the environment, and then the control group has no change. Well, it's no change, so I'll try to connect those together. So the control group just goes about as normal with no change, and the experimental group has a change. That way you can compare the results of the two groups and then you can see if whatever change you implemented had a measurable outcome on those who had that group compared to the control group that didn't have a change. If you didn't have a control group, it'd be a lot harder to tell if the difference was because of your experiment or something else. So 3 ways to collect data, 5 different ways to pick your sample group, and let's see how we can use this to our advantage or things that we want to watch out for. So problem solving tips. Simple random samples are the most common, so most of the times you'll do that, but all the others are perfectly valid as long as the results are stated in a way that takes the sample type into account. By that I mean, so say you do a convenience sample where you are interviewing people who are getting on and off of the school bus. Then if you're making a conclusion like these school children all have a sack lunch, as long as your conclusion is kids who get on and off of school buses in the morning all have a sack lunch, then it might be an okay conclusion. But if you say all students have a sack lunch, then it would be biased because you're making a conclusion about a group that's not representative of what your sample was. So you have to make sure that whatever your conclusion is takes into consideration how you got that sample. If it doesn't, then it might be biased conclusion. Okay, second thing to keep in mind, the 3 data collection types all have different strengths and weaknesses. So if we go back and look at them again, one is a survey, one is an observational study, and one is an experiment. So the amount of information you can get from an experiment may be a lot higher and better than what you can get from a survey, but it takes more time and money to do an experiment than to give a survey. So basically, the more time and money you're willing to spend, the better data you can get and the more confirmed conclusions you can draw. So it's a lot of times based on how much resources are available for the group that's doing the study. And the third one is just to reiterate over and over again that bias is a huge problem in real-world data, and I encourage you guys, anytime you're looking at whether it's homework problems in this class or just looking in the newspaper or hearing statistics online about anything, always take into consideration, could there be any bias in this data? What was the sample of individuals that they were looking at, and is that sample representative of the overall group that they're trying to make a conclusion about? Okay, so now we do a couple of sample problems and then we'll be finished with this one. So identify the sample, suggest a population from which it was selected, and tell us how it was selected, what type it is. So number 1, a homeowner is concerned about the quality of the topsoil in her backyard. The backyard is divided into 5 equal sections, and then a 1-inch plug of topsoil is randomly removed from each section. So because we divide it into sections and then take a random piece from each section, that's called stratified. So this one is going to be stratified. That's where you divide it up and then you make sure you get a random piece from each one. So stratified sample. Our sample is going to be the part that we're actually looking at. So the sample is going to be the 5 1-inch plug. So a plug of soil is just like a little a clod or a piece of dirt. So our sample is the 5 plugs. And then our population, which would be everything, is all of the soil in the backyard. So the population, start to write here, population is all the soil. Okay, so you're looking at just 5 pieces of soil to try to make a conclusion about all of the soil, to find out mineral content. Okay, number 2, a hospital's administration is interested in opening a gym on the premise for all of its employees. They ask each member of the night shift emergency room staff if he or she would use the gym, and if so, what hours the employee would prefer to use it. So because we're only asking the night shift emergency room staff, it's definitely not simple, it's definitely not stratified, it's definitely not self-selected. So would you say it's systematic or convenience? Well, they're asking a specific group. Systematic means you start at random and then you go every increment thereof. So I would say this is a convenience sample. Maybe the time at which they were able to make this survey and the location at which they were able to make this survey was at night in the emergency room. So they're only asking people who are conveniently around at that time. So this would be a convenience sample. And the sample is going to be all the people that they asked, and the population is the entire set of employees at the hospital. So probably if they made a conclusion based on this, it would probably not be very good because the other people who work at the hospital might have different opinions about when to use the gym. Okay, third one, politics. The senator wants to know her approval rating among her constituents. She sends questionnaires to the houses of 100 registered voters. Okay, so now, let's see, what kind of sample is it? It's not completely, well, let's see, is it simple? They want to know the approval rating among constituents in her state. Well, if they only send it to registered voters, then it's not necessarily going to go to everybody. So it's not self-selected. It's not stratified. It's not convenience. It's not systematic. I suppose you could say it is simple, but only to a subset, which is the registered voters. Yeah, that's a little bit tricky, in fact. So I would say it's simple because it's to random voters, but you're looking only at the registered voters. So your population in this case, is not all the people. The population is just the registered voters. So that's important to distinguish. Registered voters. And then your sample is going to be these 1,000 registered voters. So you're not getting any information at all about the non-registered voters. And of course, I said it's going to be simple because you're looking only at that subpopulation. So sometimes it takes a little bit of time. Go through each of the 5 options and make sure you kind of cross out the ones that you know it can't be and then see what's left over at the end. Okay, 2 more. Identify each sample as biased or unbiased and explain why. A company that produces motherboards for computers randomly selects 25 boxed motherboards out of a shipment of 1,500 and then tests each one to see if it meets the specs. That should be unbiased because they're selecting them randomly out of the shipment. Bias would mean they had some kind of reason why they picked certain ones over other ones, but in this case they're selecting them randomly, so that should be unbiased. Number 2, government. The first 100 people entering a county park on Thursday are asked their opinions on a proposed county ordinance that would allow dogs in county parks to go unleashed. So this one is going to be biased because they didn't ask people at random, they asked the first 100. And there might be some kind of correlation between the people who come to the park in the morning or right when it opens and whether they want their dogs leashed or unleashed versus, in general, all the people who go to the park. So if they made a conclusion about this, they could only make the conclusion about people who come to the park early, or the people who come at this time of day or something, but not all the people in general who use the park. So this one would be unbiased, and so number 4 would be unbiased, I'm saying, and then number 5 would be biased because of the reasons that we just said. Okay, that's it for section 12.1. Like I said, it's mostly vocabulary. You're identifying the different ways to create a sample out of a population, and then you're looking at different ways to collect information from that sample, and then you're seeing if the information that's collected is giving results that are going to be biased or unbiased. All right, thank you much. Oh, I lied. Here's identifying which of the 3 types of data collection. I'm so sorry. We'll go through this quickly. Music. To determine the musical preferences of their customers, the owners of a music store randomly choose customers to participate in an in-store interview. Okay? Well, is it a survey? Is it an observational study? Or is it an experiment? An interview is collecting information from the people, so an interview counts as a survey. It's done verbally instead of on paper, but it's still a survey. You're asking them questions, you're getting their responses. Administrators at a library want to know the type of materials patrons are most likely to use. They record the type of media each patron uses. So here, the person is being observed, so this record the type of material each person uses is going to be an example of an observational study. You're just watching them, not interfering, and writing down what they do. And then the last one, to determine whether the school should purchase new computer software, the technology team divides a group of 50 students into 2 groups. One group does an activity and the other group does the same one with new software. So they divide them into a control group and an experimental group. So this is definitely an experiment. Okay, because they divide one into control, one into experimental group. They each do something different, and then you can compare the results from the 2 groups. So hopefully this helps explain all the different possible combinations of things, and I'll see you in class.